This video will teach you how to build a simple device that can measure distance and display the results on a screen using an ultrasonic sensor, Arduino, and a liquid crystal display. Welcome to Coding with Arduino for Young Innovators. If you are watching this video on YouTube, kindly subscribe to the channel. Let's get started. These are the core components we will use to build the project. Number 1, a HC-SR04 Ultrasonic Sensor. It will measure the distance. Number 2, an Arduino Uno R3. It will compute the distance measured. Number 3, a 16:2 liquid crystal display or LCD. It will display the distance measured. Number 4, a 5K potentiometer. It will help us adjust the brightness of the LCD. Number 5, a 220 ohms resistor. It will help limit the current going to the backlight LED of the liquid crystal display. This is the circuit diagram of our project. Here you can see the Arduino board, the liquid crystal display, that is the 16:2 liquid crystal display. It is called a 16:2 liquid crystal display because it has 16 columns and 2 rows. Here is our HC-SR04 ultrasonic sensor. Here is the 5K potentiometer, and here is the 220 ohms resistor. We have that the VSS of the LCD is connected to ground, that is the ground pin of the Arduino board. Wherever you see GND, it is ground. And then we have the VDD pin of the LCD connected to the 5-volt pin of the Arduino board to supply power to the LCD. We have the V0 pin of the LCD connected to the middle pin of the 5K potentiometer. We have the RS pin of the LCD connected to pin 12 of the Arduino board. We have the RW pin of the LCD connected to ground. We have the E pin of the LCD. E means enable pin. So we have the enable pin of the LCD connected to pin 11 of the Arduino board. By the way, RW means read write, while RS means register select. Then we have that the DB0, DB1, DB2, and DB3 pins of the LCD are not connected to anything, while the DB4 pin of the LCD or the D4 pin of the LCD is connected to pin 4 of the Arduino board. Then the DB5 or D5 pin connected to pin 5 of the Arduino board. The DB6 or D6 pin of the LCD is connected to pin 6 of the Arduino board, while the D7 pin or the DB7 pin of the LCD is connected to pin 7 of the Arduino board. This pin is the positive LED pin of the LCD. It is connected to one leg of the 220 ohms resistor. You can also call it the A pin or the anode pin of the LCD. Then we have that the other leg of the resistor is connected to the 5-volt pin of the Arduino board. Then we have the negative LED pin of the LCD, which is also called the K pin or the cathode pin, connected to ground. Then for the potentiometer, we already know that the middle pin is connected to the V0 pin of the LCD. Then we have one extreme leg of the potentiometer connected to the 5-volt pin of the Arduino board, while the other leg of the potentiometer is connected to ground. For the ultrasonic sensor, we have the VCC pin, which is the supply voltage pin, connected to 5-volt pin of the Arduino board, and the ground pin, the GND pin, connected to ground, while we have the trick pin, which is this pin, connected to pin 9 of the Arduino board, while the echo pin is connected to pin 10 of the Arduino board. So this is how our circuit is connected. Let's now look at the physical circuit, which is connected exactly as shown in the circuit diagram. Here is the physical circuit built to match the schematic exactly. Every component is connected precisely as shown in the physical diagram. This is the Arduino board. This is the HC-SR04 Ultrasonic Sensor. This is the 16:2 LCD. That is the LiquidCrystal display where the measured distance is displayed. This is the 5K potentiometer, and this is the 220 ohms resistor. Here we have a bunch of jumper wires and a breadboard that helped us make the connections. Having seen the physical circuit, let's now look at the code for the project. We will upload the code to the Arduino board and we will see if our project is working as we expect it to work. This is the code for our project. Here you can see that we included a file. This is the LiquidCrystal display library file. If we don't include this file in our code and we are working with the LiquidCrystal display module or the LiquidCrystal display component, it will not work as we expect it. Then here we'll have a line of code that tells us the pins of the Arduino board where we connected some LCD pins. So we made use of pin 12, pin 11, pin 4, pin 5, pin 6, and pin 7. If you check the circuit diagram, you will also see that we connected some pins of the LCD to this Arduino digital pins. Then here we'll have a declaration of pins for the ultrasonic sensor. We declared pin 9 as the trick pin of the ultrasonic sensor and pin 10 as the echo pin of the ultrasonic sensor. Then we'll have another pin declaration to hold a variable called duration and distance. And then we'll have the void setup function. Remember that any code in this void setup function will run once when the Arduino is powered or when the Arduino is reset. So here we'll have that our trick pin is set to output and our echo pin is set to input. We also initialize the LCD with the function lcd.begin. Because we are using the 16:2 LCD, we also included that here. So we included 16:2. If we are using the 16:4 LCD, we will change this 2 to 4. Okay, so here we also have another line of code that is used to print character on the LCD. So we have to print this string character distance meter once because this is a void setup function. And then we set the cursor to :0, row 1 to print initializing. Then there is a delay of 2000 milliseconds. And then we use this function to clear the LCD screen. Here is the void loop function. In the void loop function, we have the code that sends out pulse. That is an ultrasound out of the transmit band of the ultrasonic sensor. So this code will help us send out ultrasound from the transmit band of the ultrasonic sensor. And then when that sound hits a barrier and reflects as echo, the receive band of the ultrasonic sensor will receive it. And then we use this line of code to calculate the time it took that pulse, that ultrasound, to be transmitted and received. Then we use this line of code to calculate the distance that is covered by the ultrasound. And then we use this line of code to set the cursor of the LCD where characters will be printed. So we set it to :0, row 0 to print the word distance. And then we set the cursor again to another position on the LCD. Here we set it to :0 and row 1 to print the distance. Now, the distance that we printed is the distance when the value is greater than or equal to 2 and that value of the distance is less than or equal to 400. The unit is centimeters. So we're talking about 2 centimeters and 400 centimeters. And then if the distance measured falls within this range, then it will be printed as the distance on the second row of the LCD. And then that will be followed by the unit of the distance measured, which is centimeters. However, if the distance measured falls outside this range, then what will be printed is a character string that says out of range. And then we'll have a delay of 200 milliseconds, after which the code in the void loop function will run again and again and again. So, having seen the code, let us now upload the code to the Arduino board and see how our circuit or how our project behaves. So let me connect the Arduino board to the computer. So we can see that we have no characters displaying on the LCD. Let me upload the code and we will observe what happens. So I will click the upload button and you can see the code is compiling. After compiling, it will upload. Remember that you can call Arduino code sketch. So the sketch is compiling. Compiling, uploading, done uploading, distance meter initializing. Now you can see that our screen is not very bright. So I will turn the potentiometer knob to adjust the brightness of the LCD. Perfect. Now we have something reasonable. So let's start measuring distance. So at the moment, I brought my barrier to a certain position, and you can see that we're measuring a distance of 12.9 cm. I will adjust the barrier and bring it closer. What do we have? We have 12.3 cm. We have 7.9 cm. We have 6.2 cm. We have 4.5 cm. I'll go back again. We have 8.9 cm. We have 12.6 cm. We have 15.4 cm. We have 20.5 cm. We have 23.4 cm. We have 14.4 cm. We have 10.9 cm. We have 6.4 cm. So with this device, you can measure distance and have the distance measured displayed on the screen. At this point, we can conclude that our project is working as expected. So far in this video, we have been able to build a contactless distance measurement device using an ultrasonic sensor, a LiquidCrystal display, and an Arduino board. If you like this video, please give it a thumbs up. Let me know your thoughts in the comment section and don't forget to subscribe to the channel. I am Instructor Izu and I look forward to seeing you in the next video where we keep building exciting Arduino projects. Bye.